What's up, guys? Yeah, so welcome to my probability interview question list. And yeah, this question is also famous, probably not so famous, but famous in the interview question. So yeah, okay, so let's solve it. And if you want to see more video, that you can click the list below. Okay, so casino offers yet another card game with a standard 52 cards, 22 red, 22 black. And then there are cards that sort of shuffle and the dealer draws card one by one. And then you can ask the dealer to stop anytime you like. For each red card drawn, you win one. For each black card drawn, you lose one. Okay, so let's see this. What's the optimal stopping rules in terms of maximizing expected payoff and how much you are willing to pay this game? Okay, so this problem is like the you can view obviously this dynamic programming, right? Because like each stage, right, you need to ask how many expected how many cards that the red and sorry, the red and the black left in the deck in the deck, right? Okay, so and for each red you draw, you win one, right? For each black draw, you lose one. Okay. Okay, so and then I mean you are smart, right? So suppose. Okay, so the idea is that this is a deck, right? There are B black, and there are blue. Okay, sorry, R red. Okay, so you can ask what's the expected the payoff or expectation of payoff, which you're gonna to ask, right? So these are the left in the deck. Okay, so let's denote the F of BR to be the expected payoff. Okay, and you're smart, right? So which means that if everything is red, there's no right, then the expected payoff will be R, right? Because you're smart, right? You will just play this game, right? Because everything is red, so you know now you always win, right? And if there is no red, then you're also smart, right? So you will get zero because you will say, oh, okay, I stop, right? So you get zero. So this is the boundary condition or the initial condition, okay? So these are the boundary condition. Okay, so so you need to like find a way to to maximize your payoff, right? So obviously that with FBR you can ask what is the transition equation, and so what is the expected payoff for this, right? Which is B minus R minus, right? So in this case, if the black card you lose one, right? So it's R minus B, right? So which is max R minus B, right? And but you need to ask the probability of the next round, right? So maybe if you have R plus B probability that you get the one R, right? So you get F B R minus one, right? Because you lost one R, and also you have this, and you lose one B. Right, so this is the expected payoff, and if you need to ask how's this payoff compared to if you start to draw, right? This is you start to draw the next. Okay, so the easy way is so now you can just write this equation and using this to solve it. Okay, and ask what is F 26. Okay, so in principle you can just directly solve it, but I mean the naive way is you can just write a code, right? So let me just do this. Okay, and hopefully I get things correct. Okay, so should be very simple. So let's write the code. Yeah, I just go to find the online Python compiler. So let's do this, right? So I want to define this FBR, right? And so if B is 0, then I should return R, right? So and else if R is 0, then I should return B. So I should return 0, right? Else that I should return the max of B minus R, B divided by B b plus r, and the f times this f, b minus 1, b minus 1 r plus this, right? Plus this. Okay. But and then you can run like f26, 26. Okay, and you will take a lot of time, right? Because you are not using, you are just keep recursive, sorry. So you will ask this the same thing again. Okay, so the standard approach is that you just create a dictionary and you just ask whether if these b are already in a dictionary, then you just return that dictionary, right? You return br, right? Otherwise that you can just otherwise that you it's for answer, and then that m of br to be the answer, and the return is okay. So now you can solve it. Okay, I solved it, but I didn't print it. Let's see. So, oh, sorry, how stupid is RMSP. Okay, so I think this is the common answer that you can follow in the textbook. So textbook answer should be this. Yeah, so this is the code that you can solve this question. Let me just copy this code into my PowerPoint so that you guys can just check. Oh shit. Oh, okay. I mean, it's you okay. So you know. Okay. So yeah, that's it. Hope you guys subscribe to my channel.